The story you are about to hear is based on real historical events. Please note that while the history is real, the images and footage shown in this documentary are generated using AI for illustrative purposes. In the summer of 1943, American bomber crews flying over Nazi-occupied Europe faced a problem that was killing them by the thousands. They were dropping bombs from 25,000 feet through clouds, through flak, through fighter attacks, and those bombs were missing their targets by miles, not feet, miles. Entire formations would release their payloads over what they believed was a German factory, only to obliterate empty farmland 3 miles away. The Germans knew this. They watched American bombers dump tons of high explosives into forests and fields while the actual war industries hummed along untouched just beyond the smoke. The 8th Air Force was bleeding crews at unsustainable rates, and for what? Craters in cow pastures. Then something changed. Suddenly, impossibly, American bombs started falling with surgical precision. Railway junctions obliterated. Submarine pens collapsed. Oil refineries turned to ash. The Germans couldn't understand it. How were the Americans suddenly dropping bombs into targets the size of pickle barrels from 5 miles up? The answer was a secret so closely guarded that even most bomber crews didn't know it existed. A secret that cost more than the Manhattan Project. A secret built on mathematics, mechanical wizardry, and the most sophisticated analog computer ever designed. The weapon was called the Norden Bombsight. And this is the story of how it turned American bombers into precision instruments of destruction. Before we understand the secret, we need to understand the nightmare. Strategic bombing in World War II was supposed to be the war-winning weapon. The theory was elegant. You didn't need to engage enemy armies on the ground. You didn't need to sacrifice millions of soldiers in trench warfare like World War I. You simply flew over enemy territory and destroyed their ability to make war. Bomb the factories, bomb the refineries, bomb the railways. Starve the war machine of steel and fuel and transport, and the enemy would collapse without a single ground battle. That was the theory. The reality was that hitting anything from 20,000 feet was nearly impossible. The bomber was moving at 200 miles per hour. The target was 5 miles below, often obscured by clouds or smoke. Wind pushed the falling bomb off course. Air pressure affected its trajectory. The curvature of the Earth had to be calculated. By the time a bombardier saw his target, calculated the release point, and toggled the bombs, the aircraft had already flown past the optimal drop zone. Early bombing missions in Europe were exercises in futility and death. American crews would fly through walls of German flak, lose aircraft to Luftwaffe fighters, dump their bombs somewhere near the target area, and return to base with empty bomb bays and empty seats where their friends had been. Intelligence officers would analyze reconnaissance photos and grimly report that the mission had achieved nothing, except more names on the casualty lists. The British had already concluded that precision bombing was impossible. They had tried it in daylight during the early war years and watched their bomber fleet get slaughtered by German defenses. So they switched to night bombing, to area bombing, to the deliberate destruction of entire cities rather than individual targets. If you couldn't hit a specific factory, you could at least burn down the city that contained the factory. It was brutal, indiscriminate, and strategically questionable, but it was all they believed was possible with existing technology. The Americans disagreed. They believed that with the right equipment, you could drop bombs with enough precision to destroy point targets without resorting to city burning. And they had a device that they believed could make this possible: the Norden Bombsight, a mechanical analog computer so sophisticated, so revolutionary, that the United States government classified it above top secret and spent more money developing and producing it than they would later spend on the atomic bomb. The Norden bombsight was the invention of Carl Norden, a Dutch engineer who had immigrated to America and become obsessed with the problem of accurate bombing. Norden was a perfectionist, brilliant and difficult, a man who believed that any engineering problem could be solved with sufficient precision and clever design. In the 1920s and 30s, working with the United States Navy, he developed a series of increasingly sophisticated bomb sights. The final version, the Mark 15 Norden bombsight, was a masterpiece of mechanical engineering. It weighed about 50 pounds. It contained more than 2,000 moving parts, gears and gyroscopes and mirrors and levels, all machined to tolerances measured in thousandths of an inch. It cost $8,000 per unit in 1940s money, which translates to well over $100,000 today. And it could calculate, in real time, the precise moment to release bombs to hit a target with an accuracy that seemed impossible to those who didn't understand the mathematics behind it. Here's how it worked. The bombardier would locate the target through the Norden's telescopic sight. He would input data, altitude, airspeed, wind speed and direction, the temperature and air pressure, the weight and ballistic characteristics of the bombs being carried. The bombsight's internal computer, an intricate arrangement of mechanical gears and cams, would process all this information. Then the bombardier would engage the automatic flight control system, and here's where it gets remarkable. The Norden bombsight would actually fly the airplane. The bombardier, looking through the sight, would use control knobs to keep the crosshairs aligned on the target. Those adjustments were fed directly to the aircraft's autopilot, which controlled the plane's heading and speed. The pilot's job was to maintain altitude. The bombardier flew the bombing run. The bombsight calculated, constantly, the trajectory of bombs that hadn't been released yet, factoring in how the airplane's speed and position were changing. When the internal calculation determined that the optimal release point had been reached, the bombardier would press a button, or in automatic mode, the bombsight itself would trigger the release. The bombs would fall. And if everything was calibrated correctly, if the inputs were accurate, if the machinery functioned as designed, those bombs would strike within a circular error of just 75 feet from 5 miles up. 75 feet from 25,000 feet altitude. That was the claim, that was the promise, and it was so far beyond what any other nation could achieve that the United States military treated the Norden bombsight as perhaps the single most valuable secret of the entire war. Bomber crews were told that the Norden was more secret than any other piece of equipment they carried. They were instructed that if they were shot down over enemy territory, their priority was to destroy the bombsight before bailing out or crash landing. Thermite grenades were installed in every bombardier station, specifically to melt the Norden into slag if capture seemed imminent. Crews faced court-martial if they failed to destroy their bombsight and it fell into enemy hands. The security around the Norden's manufacture was suffocating. Workers at the Norden factory were forbidden from discussing their work. Different components were made in different facilities, so no single worker understood the complete design. Guards watched every step of production. Before each bombsight left the factory, it was tested, calibrated, and sealed. When bombsights were shipped to air bases, they traveled under armed guard in specially designed cases that could be quickly destroyed if intercepted. The paranoia was justified. If Nazi Germany obtained a working Norden bombsight and successfully reverse-engineered it, they could potentially build their own. And while Germany's bomber fleet had been reduced by the demands of the Eastern Front, the thought of German bombers equipped with Norden-level accuracy was terrifying. More immediately, if Germany understood how the Norden worked, they might develop countermeasures. Electronic jamming. ways to fool the gyroscopes or corrupt the calculations. The advantage that America possessed would evaporate, so the secrecy was absolute. Bomber crews called the Norden the football because of its shape and because it was protected like nothing else they carried. Maintenance crews who worked on the Norden required special clearances and worked in guarded areas. Even within the military, information about the bombsight's capabilities and design was restricted to those with explicit need to know. But here's the thing about secrets. They only matter if they work, and the Norden bombsight did work, at least under the right conditions. When American bomber formations struck targets in clear weather with experienced bombardiers with properly calibrated equipment, the results were devastating. Precision that Nazi military planners had believed impossible suddenly became routine. The August 1st, 1943 raid on the Plosti oil fields in Romania saw American B-24 Liberators flying at low altitude, not using the Norden due to the tactical situation and suffering catastrophic losses. But high-altitude missions using the Norden achieved results that terrified the German war machine. The Schweinfurt ball-bearing factories, vital to German aircraft and tank production, were hit with such precision that production dropped dramatically. Submarine pens, thought to be invulnerable under their thick concrete roofs, were rendered unusable when Norden-guided bombs collapsed the dock facilities surrounding them. The Germans captured their first Norden bombsight in early 1943 when a damaged B-17 crash-landed in occupied territory, and the crew was unable to destroy their equipment before capture. German engineers examined it with a mixture of admiration and dismay. They recognized immediately that the device was generations ahead of German bombsight technology. The precision machining, the sophistication of the calculations, the integration with the aircraft's autopilot, all of it was beyond what German industry could replicate quickly. They tried. German engineers produced detailed technical drawings. They attempted to manufacture copies, but they faced insurmountable problems. German industry was already stretched to its limits, producing fighters and tanks and submarines. The materials required for the Norden's precision components were in short supply. The manufacturing tolerances were beyond what most German machine shops could achieve. And even if they could build the hardware, the Norden required extensive training to use effectively. You couldn't just hand it to a bombardier and expect results. It required hundreds of hours of practice. And by early 1943, Germany didn't have hundreds of hours to train bombardiers. They barely had enough bombers left. So the Germans did what they could. They studied the Norden to understand American bombing tactics. They looked for weaknesses to exploit, and they found one. The Norden bombsight, for all its sophistication, required one thing it couldn't provide itself: clear visibility of the target. If clouds obscured the target, the Norden was useless. The bombardier couldn't align the crosshairs on something he couldn't see. Germany's weather provided natural defense. The cloudy, overcast skies over northern Europe meant that many American missions arrived over their targets only to find them completely obscured. Missions would be scrubbed. Bombs would be dumped on secondary targets or targets of opportunity. The vaunted precision of the Norden meant nothing when the bombardier was staring at a solid blanket of white clouds. The 8th Air Force experimented with formation bombing, where only the lead bombardier used the Norden and the entire formation released when they saw the lead ship's bombs drop. This worked, but reduced accuracy significantly. They tried radar bombing, but early radar couldn't provide the resolution needed for precision targeting. The Germans also realized that they could make American bombing less accurate through a tactic that sounds almost absurd: smoke generators. When German intelligence detected that an American raid was approaching a specific target, air raid sirens would sound not just to warn civilians, but to trigger defensive measures. Within minutes, hundreds of smoke generators positioned around vital factories would ignite, producing thick, oily smoke that would rise thousands of feet and obscure the target area. American bombardiers, looking through their Norden sights, would find their targets completely hidden under artificial clouds. They would estimate drop points based on where they thought the target was beneath the smoke. Accuracy plummeted. Bombs fell on residential areas, on empty lots, on fields, anywhere but the intended aim point. The Norden was a precision instrument, but precision required being able to see what you were aiming at. Despite these limitations, the Norden bombsight gave American strategic bombing a capability that no other air force possessed. The RAF, flying at night to avoid German fighters, had to rely on area bombing because they couldn't even see individual buildings, let alone aim at them. The Soviet Air Force focused on tactical ground support and had neither the heavy bombers nor the technology for strategic precision bombing. The Luftwaffe had been forced into a primarily defensive role, their bomber fleet decimated by losses on the Eastern Front and the demands of defending German airspace. Only the United States Army Air Forces had both the heavy bombers to reach deep into enemy territory and the technology to hit point targets with devastating accuracy when conditions allowed. This capability shaped American strategic doctrine. While the British attacked cities at night, the Americans attacked specific industries by day: oil refineries, aircraft factories, transportation hubs. The theory was that by surgically removing the components of the German war machine, you could achieve strategic effects without needing to burn entire cities. The reality was more complex. Civilian casualties from American precision bombing were still substantial. Even with the Norden, bombs that missed their aim point by 200 feet could devastate residential neighborhoods adjacent to industrial targets. And when clouds forced bombardiers to use radar or dead reckoning, American bombing missions could be just as indiscriminate as RAF area raids. But the Norden gave American planners options. They could choose to target specific facilities. They could plan missions around weather forecasts, waiting for clear days when precision would be possible. And when the Norden worked as designed, the results justified its enormous cost. Consider the attack on the Focke-Wulf aircraft factory in Bremen on October 8, 1943. This facility produced German fighters that were taking heavy tolls on Allied bombers. The factory needed to be destroyed, but it was located in a dense urban area. A carpet bombing raid would kill thousands of civilians. The 8th Air Force planned a precision strike. B. Flying fortresses, each bombardier with a Norden sight would attack the factory complex in daylight. Intelligence estimated that if the factory could be knocked out for even 3 months, it would significantly reduce the number of new fighters entering Luftwaffe service. The mission was dangerous. Bremen was heavily defended, but the weather was forecast to be clear. The raid went forward. Bombardiers acquired their targets through the Norden sights. The lead bombardier aligned his crosshairs on the main assembly building. The formation released. Post-strike reconnaissance showed that the factory had been devastated. The assembly building collapsed. Machine shops destroyed. The production line obliterated. Civilian casualties were a fraction of what an area bombing raid would have inflicted. The Focke-Wulf facility was out of action for months. The Norden had worked exactly as advertised, but missions like Bremen were the exception, not the rule. Studies conducted after the war showed that overall American bombing accuracy was nowhere near the theoretical capability of the Norden bombsight. The average bombing mission in Europe saw only about 20% of bombs falling within 1,000 feet of the aim point. Weather, flak, fighter attacks, equipment malfunctions, crew inexperience, all of these degraded accuracy. The Norden was capable of 75-foot accuracy in perfect conditions. Perfect conditions existed rarely in wartime. What the Norden did provide was a significant improvement over what was possible without it. And in strategic bombing, where success was measured in percentage of targets destroyed across hundreds of missions, even modest improvements in accuracy had enormous cumulative effects. A bomb that landed 500 feet from the aim point, instead of 2,000 feet, was still far more likely to cause meaningful damage. The Pacific Theater presented different challenges and different successes for the Norden bombsight. Japanese targets were often spread across vast distances, and weather over the Pacific was notoriously unpredictable. Early Pacific bombing missions faced many of the same accuracy problems as European missions. But as the war progressed and American forces captured islands closer to the Japanese home islands, the Norden became increasingly effective. The systematic destruction of Japanese urban industrial areas combined area bombing with precision targeting of specific factories and facilities. The March 9th, 1945 firebombing of Tokyo was an area raid that didn't require precision bomb sites, but subsequent missions against Japanese aircraft factories, oil storage facilities, and transportation networks used the Norden to devastating effect. By mid-1945, American bombers were ranging across Japan almost unopposed, and bombardiers with Norden sights were hitting targets with an accuracy that Japanese defenders found incomprehensible. The cost of the Norden program was staggering. Between development, production, and training, the United States spent approximately $1.5 billion in 1940s money on the Norden bombsight system. To put that in perspective, the Manhattan Project, which developed the atomic bomb, cost about $2 billion. The United States spent almost as much on a mechanical analog computer for aiming bombs as it spent on creating nuclear weapons. Critics after the war questioned whether this expenditure was justified. The actual combat accuracy never approached the theoretical precision. Cheaper, simpler bomb sights might have achieved almost as good results at a fraction of the cost. But these critiques miss the strategic context. The Norden bombsight gave American military planners confidence that precision strategic bombing was possible. This confidence shaped doctrine, resource allocation, and operational planning. It meant that when American bombers flew into flak-filled skies over Germany and Japan, they were attempting to hit specific targets, not just dropping bombs randomly and hoping for the best. And even if the achieved accuracy was far below the theoretical maximum, it was still substantially better than any alternative method. The secrecy surrounding the Norden began to relax slightly in late 1944 as the war's outcome became increasingly certain. But even then, the device remained highly classified. It wasn't until the 1950s that technical details of the Norden were declassified, and even then, much of the sophisticated manufacturing knowledge remained restricted. By the time the Norden's secrets were fully revealed, the bombsight was obsolete. Radar bombing, and later guided missiles and precision-guided munitions, rendered mechanical analog bombsights irrelevant. The Norden represented the absolute pinnacle of pre-computer mechanical calculation, and it was made obsolete within a decade of the war's end by electronic systems that could do in milliseconds what the Norden's gears and gyroscopes required seconds to accomplish. But during World War II, during the crucial years when the strategic bombing campaign was either going to cripple the Axis war machines or prove to be a costly failure, the Norden bombsight was the difference between precision and guesswork. It allowed American crews to at least attempt surgical strikes on vital industries. It gave planners the option to target specific facilities rather than just areas. And it created in the minds of enemy planners the terrifying reality that American bombers could hit targets that should have been untouchable. A railway junction in the middle of a city struck and destroyed while surrounding buildings stood. A transformer station knocked out while the factory it served remained intact, waiting for power that would never come. These were the kinds of effects that the Norden made possible, not consistently, not with perfect reliability, but often enough to matter, often enough to be worth the enormous cost and the obsessive secrecy and the thousands of bombardiers trained to use a device that they were told was more secret than almost any other weapon in the American arsenal. The story of the Norden bombsight is ultimately a story about American strategic thinking in World War II. The decision to invest massive resources in a precision bombing device reflected a belief that wars could be won through technological superiority and industrial targeting rather than through attrition and mass destruction. Whether that belief was fully validated by the war's outcome is debatable. The strategic bombing campaign against Germany achieved important effects, but it didn't cause the collapse that pre-war theorists had predicted. German industrial production actually increased through 1944 despite sustained bombing. The final defeat of Germany required ground armies fighting through France and into Germany itself. But the bombing campaign, enabled by devices like the Norden, forced Germany to divert enormous resources to air defense, resources that might otherwise have gone to the Eastern Front. It destroyed transportation networks and oil production capacity at critical moments, and it demonstrated American technological capability in ways that affected enemy morale and planning. In the Pacific, strategic bombing played a more decisive role, and the Norden bombsight was crucial to missions that isolated Japanese forces and destroyed their industrial capacity. By the time the atomic bombs were dropped on Hiroshima and Nagasaki, conventional bombing using precision and area methods had already devastated much of Japan's urban industrial infrastructure. The Norden had been part of that campaign, guiding bombs to oil refineries and aircraft factories and port facilities with an accuracy that pre-war Japanese planners would have thought impossible. The security around the Norden also reflected a broader American approach to military technology. If you had an advantage, you protected it obsessively. You assumed the enemy would do anything to steal or replicate it. You built elaborate security protocols to prevent compromise. This sometimes reached absurd levels. Bomber crews were more concerned about protecting their bombsight than protecting their actual bombs. But this paranoia was often justified. Germany and Japan both ran extensive intelligence operations attempting to steal American military technology. Both would have prioritized obtaining Norden bombsights if they believed they could be captured intact and successfully reverse-engineered. The fact that captured Nordens never gave the Axis powers any useful capability says less about the quality of German or Japanese engineering, and more about the industrial and material realities of the war by the time they obtained examples. By 1943, when Germany got its first intact Norden, German industry was being hammered by Allied bombing and was desperately short of resources. Building a precision device requiring thousands of hours of skilled machining using scarce materials was simply impossible. Training crews to use it effectively was impossible. The Luftwaffe was barely able to maintain the aircraft it already had. Japan faced even more severe resource constraints. Capturing American technology was interesting from an intelligence perspective, but useless from a practical military perspective. They couldn't replicate it, and even if they could, they didn't have the strategic bombing capability to make use of it. By late war, both Axis powers were in survival mode, focusing on fighter production and anti-aircraft defenses, not on developing sophisticated bombing systems. The human element of the Norden story deserves attention. The bombardiers who used it were skilled technicians, trained for months on the device's operation and care. They were responsible for the most critical moment of every bombing mission, the moment when bombs were released. If they calculated wrong, if they compensated for the wrong wind, if they toggled the release a second too early or too late, the mission failed. Thousands of feet above enemy territory, surrounded by flak, possibly with fighters attacking, these young men would peer through their Norden sights and make microscopic adjustments to keep the crosshairs aligned on targets barely visible below. The pressure was enormous. The responsibility was crushing, and they did it knowing that their bombsight was considered more valuable than they were. Instructions were clear: destroy the Norden before you allow yourself to be captured. Your life matters less than this machine. That must have been a strange psychological burden to carry, being literally less important than the equipment you operated. Carl Norden himself lived to see his invention become obsolete. He died in 1965, having watched the device he spent decades perfecting become a museum piece within 20 years of the war's end. He defended the Norden's reputation vigorously, arguing that when used properly by trained crews, it achieved the precision he had designed it for. He wasn't entirely wrong. Under optimal conditions, the Norden could do everything promised. But optimal conditions were rare in combat. His perfectionism, his insistence on minute tolerances and complex mechanisms, created a device that was brilliant in theory and problematic in practice. A simpler, more robust bombsight might have been more effective overall, even if its theoretical maximum accuracy was lower. This is a common tension in military technology. The most sophisticated solution is not always the most practical solution. The legacy of the Norden extends beyond World War II. It influenced the development of guidance systems for missiles and eventually for precision-guided munitions. The underlying mathematics of ballistic calculation, trajectory prediction, and real-time compensation for environmental factors all trace lineage to analog computers like the Norden. Modern weapons that can guide themselves to targets with meter-level accuracy owe a philosophical debt to Carl Norden's obsessive pursuit of precision. The idea that you could calculate in advance the exact trajectory required to hit a target and then execute that trajectory reliably was revolutionary in the 1930s. Now it's fundamental to every guided weapon system. The Norden was an evolutionary dead end in terms of mechanical analog computation. But the principles it embodied evolved into the guidance systems that define modern warfare. For historians studying World War II, the Norden bombsight is a fascinating case study in how technology shapes strategy and how strategic requirements drive technological development. The American commitment to daylight precision bombing created demand for a precision bombsight. The development of the Norden enabled doctrine that emphasized surgical targeting of industrial systems. The mixed results of that doctrine influenced post-war thinking about strategic bombing and nuclear targeting. If you couldn't reliably hit a factory with thousands of pounds of high explosives, how would you hit a missile silo with a nuclear warhead? These questions drove the development of inertial guidance systems and eventually GPS-guided weapons. The Norden was a step along that path, an early attempt to make bombing a science rather than an art. The Pickle's barrel claim, the assertion that bombardiers could drop bombs into targets that small from 25,000 feet, became legendary. Whether it was literally achievable is debatable. Some extraordinarily skilled bombardiers under perfect conditions might have managed it, but it was never routine. The phrase represented aspiration more than reality. What mattered was that American military planners believed it was possible, and that belief shaped how they approached the air war. They planned missions assuming that targets could be hit precisely. They allocated resources on the assumption that strategic bombing would be effective. And while the results never matched the most optimistic predictions, the sustained campaign did contribute to Allied victory in ways that are still debated by historians. The Norden was part of that campaign, a tool that sometimes worked brilliantly and sometimes failed completely, but which always represented American technological ambition and industrial capability. If you want to uncover more lost secrets of World War II, make sure to subscribe to WW2 War Rewind and turn on notifications. We are rewinding history, one story at a time.